dear students. So today we will describe about Csmacd, that is carrier sense multiple access with collision detection. Okay, so collision detection means what? That means this is a multiple access channel. That means there are so many means a single channel is shared by multiple hosts. Okay, so when a channel is when a particular host is sending any informations to the channel, then what will happen? Then the channel is busy, and at the same time when another station also wants to send the data through this channel, then there is a collision, there are some collisions can occur. So in this algorithm here we need to detect the collision. Okay, so Csmacd, this is for collision detection. Okay, so that means you have to sense whether the carrier is present or not. Okay, and according to that you need to decide that you want to send the data or not, and if there is any collision occurred in that channel, that must be detect. Okay, it can be detect. So how it can detect a collision? So see, here we have 4 stations A, B, C, D. 4 stations are here, and station A is transmitting a frame with the time t1. Okay, so first bit of A is passing here, and at t4 time, at the transmission time t4, okay, is this time. See, this is the t2. So we are dividing this channel into t1, t2, here is t2, then t3 and t4 in this way. So when suppose C is sending the data here at the t2 time, and it can send the data to D as well as it can send the data to E. C wants to send the data to both of these two things. So when C wants to send the data, in that case what will happen? Here in this joint the collision occurs. Okay, so that means the two frames are collide with each other, and in this case when there is a collision, this collisions is occurred, then there a signals is generated. So that signal is called jamming signal. Okay, so this jamming signal need to send to each and every stations. Okay, so this jamming signal is responsible to send the message to each and every host that there are collisions is occurs inside the channel. Okay, so when this jamming signal is received by the different host, then they should be wait for some time to send their next data. Okay, so this is the how the collisions is detected, that is the using this jamming signal. A signal is generating here, and that signal is sending to each and every host at that channel. See, this is the transmission time. So parts of A's frame here, and so A's frame is passing, and this is the C's frame, and they are collide here. So this is the collision point, this is the collision point, and here this signal is passing here, and A detects collisions and aborts. That means A need to abort, that means A need to send the packet again, and here also C detects the collisions and aborts. So this signal, this jamming signal sent to the sender as well as receiver both. Okay, so two machines, so A and C, they can get this signal, and they have to abort their informations. That means they have to resend their data again. So this is the flow diagram for the Csmacd. So here we have the station has a frame to send, at first, and here we have k is number of atoms. K is equal to what? That is number of atoms. Tp is equal to what? That is maximum propagation time. Tp is the maximum propagation time. TFR is the average transmission time for a frame. So this is the average transmission time. TB is the back of time. So these timings you have to know: K, TP, TFR and TB. So these times are there. So at first k is equal to 1, that means number of atoms is is equal to 0, number of atoms is 0. So apply one of the persistence methods. So you have to apply one persistence, non-persistence or p persistent. We have discussed this persistent method previously. So 3 persistent methods are here. So you need to apply one of them, and then transmission done or collision detected. What is actually going on here? So eligible for transmissions. So there is a condition checking. Where is that? That means the transmission is done or collision is detected. If yes, okay, then you have to check that the collisions is detected. If collision detected, then what will happen? If it is yes, then send a jamming signal, or if it is no, then success. Okay. And transmission, if the transmission transmit and receive transmission, that means if collisions is not cannot happen, then what will be do? That is transmit, the data must be transmit and it can receive, and again you have to send another data. This process will be going on. Similarly, if there is a collision, if collision is detected, then send the jamming signal to the different hosts and increase the value of k, that is you need to attempt again. So k equal to k plus 1 and k max, k greater than k max, you should have a maximum attempt time. So that is normally 15. So if k greater than k max, if it is yes, then you have to abort, then you have to quit that frame, otherwise you have to go ahead. So if it is no, then choose a random number r between 0 to 2 to the power k minus 1. So you have to choose that random number and then you have to calculate the waiting time. So you need to wait for this amount of time after means before sending the frame again. Okay. So TB equal to r into TP. TP is the maximum propagation time, or you can calculate it using r into TFR, that is transmission time for a frame. Just do these operations and wait for that amount of time, okay, to avoid the collision, to send the data successfully. So again you have to do the second thing, that is this operations is going on. So in this way the whole things will be going on. So this is a carrier sense multiple access with collision detection. Okay. So these are the different these are the energy level during transmission and idleness or collision. So here the frame transmission is going on, and when collisions is occurred, then the energy level becomes high, and after that and this is when the frames are idle, the channel is idle, then the energy level is this. Okay. And when the collisions is going on, so it will be the channel is much more busy, and after that again the frame transmissions is going on. So this is the energy level during transmission, idleness and collision. So this is the carrier sense multiple access with collision detection. Okay. And another thing, that is carrier sense multiple access with collision avoidance. Okay. So collision avoidance, that means you need to avoid the collision. So that means there are some situations when we can't detect the collision. Okay. And in that case we need to avoid the collision. Okay, so we need to avoid the collision. So when suppose if you have means wireless channel, in that case how you can provide this jamming signal. It can when the signals is suppose there is a collisions, and if there is any signals generate, then when it means sending to different stations, maybe the signal can lost. Okay, the data can lost because the channel is wireless. So there are different noises are there in the free space, so the channel can be lost. So when we are transmitting our data through a wireless medium, then it will be better to avoid the collision. Okay, so to avoid the collisions, we have to do what? So at first you have to, the host have to check the channel again and again. So they need to continuously check the channel. So this is the continuously sensing the channel, and after that if it is busy, then you have to wait. If it is busy, then it has to be wait, and then when it just sense that the channel is idle, then what we'll do, that is you need to wait for interframe space time, that is IFS. Okay, so the gap between two frames has to be maintained. Okay, so IFS, that is interframe space. Okay, so interframe space need to be just wait for the IFS time. When you sense, when the host is sensing the channel is actually idle, but in that time also they have to be wait for IFS time, interframe space time, and after that they can send the data. Then there is a contention window, that is the size of the size of this window is binary exponential size. So there is a contention IFS time. After that the window size, what is the size of the window, that you have to avoid, that space you need to provide, and after that you can send the data. So to avoid the collision, you need to wait a long time after detecting that the channel is idle. Okay, so in this way you can host can avoid the collision. So in CSMA-CA, the IFS can also be used to define the priority of a station or a frame. Okay, so interframe space, it can be used to define the priority of a station, which station can send the data at first and which is not. Okay, so if this sequencing is there, this priority based is there, then the collisions, you can avoid the collisions. Otherwise, suppose all of these stations are actually sensing that channel is idle, in that case all of them can send the data at the same time. So if there is any priority based, that this channel will be sent at first and another will be second. So if this is given according to the IFS, and IFS can also use for that purpose also. So here, so you can avoid the collision. So in CSMA-CA, if the station finds the channel is busy, it does not restart the timer of the contention window. It stops the timer and restarts it when the channel becomes idle. Okay, so obviously the timer you should off when the channel is busy, and you have to start your timer when the channel becomes idle. So this is the flow diagram of CSMA-CA. Okay, so in CSMA-CA, what we actually doing, we just start. There also a value k equal to 0, this is here. So if the channel is idle, if it is yes, then wait for IFS time. If channel is idle, then you have to go ahead. You have to, the host have to maintain these points, these things. So if it is no, if channel is not idle, then that means the channel is busy, then again you have to check the channel. So this is the repeating process. And when the channel is idle, then wait for, at first wait for IFS time. interframe space. So you have to wait for IFS time, and after that again you have to check still idle. If it is no, then again go for this one. If it is yes, then choose a random number r between 0 and 2 to the power k minus 1. Okay, that is the contention window size. So you have to wait, you have to choose a number r between this 0 to 2 to the power k minus 1, and then wait r slots. You have to wait that amount of time, r slots. This is the it is the contention window size. So you have to wait the slots, and after each slot, if idle, continue, if busy, halt, and continue with when idle. So after that wait for r slots, and then you can send the frame. So this is the thing, that this is the slot, the contentions window slot. So you have to wait for IFS time, IFS interframe space, and then there is a contention window size. What is the window, whole window size? So that means the size of the frame. You need to also wait for that frame size also, and after that you can send the frame. So send the frame then and wait timeout. Okay, so this is the third step, this is the fourth step and fifth step, and after that wait for time out. When the time out, then if acknowledgement received, if it is yes, then success. If acknowledgement not received, then increment your value of k, that is the attempting time. You should increase this value, k equal to k plus 1, and if k greater than 15, okay, if it is yes, then abort, if it is no, then go. So this algorithm also very effective, and see, the algorithms are more or less same. That means the techniques, that means the waiting time calculations, that is r, you should take a random number, and the random number between 0 and 2 to the power k minus 1. These are almost same for CSMA, CD and CSMA CA, but difference is that in case of CSMA CD, there is the waiting time is not much more, because there may be some collisions, the collisions can be detected. Okay, so the waiting time is not much more. So after sensing that the channel is idle, then host can send the data, and for CSMA CA you have to avoid the collision. So you need to wait much more time after sensing the channel is idle, because each and every stations are sensing the channel, and they can get the value that the channel is idle at the same time, and they want to send the data at the same time. So again there can be a collision, so they need to wait for some time. And the timing, you have to remember the timing, how many times, how much time they need to wait. So there is IFS time, wait for IFS time, and after that you have to wait for r slots. So this waiting factor is here, remember it. Okay, so IFS time, interframe space gap, so this time, and the r slots, that is you should take a random number which is between 0 and 2 to the power k minus 1, and this is actually the window size. So window size means what that means the contention window, what you actually knew about this window before. So this window size you have to wait, this is the for r slots, and after that you can send the frame. Okay, so there is 2 waiting time, and in case of CSMA CD, you just transmit the data. When you sensing that the channel is idle, then you can apply this one of this persistent technology, one persistent, non-persistent, or it can be p persistent. Okay, so you can use this persistent method, and after that you can transmit the data, and after transmissions, if there is any collisions, then you can send the jamming signal. Okay, so these two algorithms are very important, and these are very straightforward algorithm, and just you have to remember the waiting time. Okay, how much time frame need to wait after sensing the channel is idle. Okay, so this is CSMA CA.